We're basically living on a tiny planet hurtling through a cosmic shooting gallery. Now, most of the bullets are pretty small, but not all of them. So, what are the real threats that are lurking out there in the dark? Well, in this explainer, we're going to rank them from the everyday stuff all the way to the civilization enders. It sounds kind of crazy, but our planet is under constant fire. Every single day, something like 100 tons of space junk, dust, little tiny rocks, just rains down into our atmosphere. Most of it just burns up harmlessly, creating those beautiful shooting stars you might see at night. So, that constant sprinkle of dust, that's one thing. But what about the bigger stuff? The ones that don't burn up, the ones that have the potential to do some real serious damage? Well, that's exactly what we're here to break down. All right, so here's our game plan. We're going to rank these cosmic threats on a scale of 1 to 5, starting with fiery storms from our very own sun, and then we're going to work our way all the way out to these wild, unpredictable wanderers of the galaxy. First up on our list, threat level 1, solar weather. The best way to think about this is like hurricanes in space. Yeah, they aren't solid objects flying at us, but they are absolutely the most common and immediate cosmic threat to our modern way of life. So, what exactly is a geomagnetic storm? Well, it all kicks off when the sun basically has a tantrum and throws a massive burst of energy and charged particles our way. When that solar storm slams into Earth's magnetic shield, it just overloads the whole system, causing this huge disturbance that can have some pretty serious consequences for us down here. And here's the problem. That disturbance directly messes with all our tech. A really powerful storm can heat up and expand our upper atmosphere, creating drag that can literally pull satellites right out of the sky. And this isn't just about your phone's GPS going wonky. We're talking about critical defense systems, from radar to submarine detection. The entire technological backbone of our modern world is, honestly, surprisingly fragile. Okay, let's level up the threat, shall we? Threat level 2, incoming rocks. This is what most people think of when we talk about cosmic threats. Asteroids. And unlike solar weather, this is a bullet we are actively learning how to dodge. And hey, this isn't just a what-if scenario. This happened, like just recently. Astronomers found an asteroid they named 2024 YR4. As they tracked it, the odds of it hitting Earth just kept climbing, eventually reaching a pretty nerve-wracking 1 in 33 chance. For a few weeks there, it was a genuine concern. Thankfully, new data showed it would miss us. But here's the catch. It now has a 1 in 25 chance of hitting the moon in 2032. We dodged a bullet by basically letting it get redirected at our closest neighbor. Finding these things is the job of some incredibly dedicated people, like Greg Leonard. He's an asteroid hunter, and he spends his nights just scanning the skies for these tiny little moving dots. This quote from his mentor, the legendary Eugene Shoemaker, it really just captures the whole spirit of planetary defense. Just being in the right place at the right time to make that one discovery that could save everyone. And here's the part that's, well, a little terrifying. We are actively trying to track asteroids that are bigger than 140 meters. That's large enough to wipe an entire city off the map. And what this chart shows us is that we've only found 45% of them. That means over half, more than half, of these potential city killers are still out there, just floating around in the dark, totally undiscovered. But it's not all doom and gloom. We are actually fighting back. Back in 2022, NASA's DART mission was a massive success. They literally crashed a spacecraft into an asteroid on purpose, and they proved that we can change its path. Now, it was a tiny little nudge in the grand scheme of things, but it was this monumental proof of concept. For the very first time, we know that planetary defense isn't just science fiction. It's actually possible. All right, time to escalate. We're moving up to threat level 3, planet killers. We're talking about extinction-level events now. An impact so huge it doesn't just destroy a city or a region. It triggers a global climate catastrophe, something called an impact winter, that threatens pretty much all life on Earth. To even try and wrap our heads around the kind of power we're talking about here, just think about this. The atomic bomb dropped on Hiroshima was about 16 kilotons of TNT. The asteroid that wiped out the dinosaurs, that released the energy of 100 million megatons. That is over 6 billion times more powerful. It's not just bigger, it's a completely different scale of reality. It's a force of nature so big our brains can barely even process it. Because here's the crucial thing. The blast itself isn't the main killer, no. It's the chain reaction that happens afterward. The impact blasts trillions of tons of pulverized rock high into the atmosphere, and this cloud just spreads, blocking out the sun. Global temperatures just plummet, photosynthesis grinds to a halt, killing off the plants, and then the entire food chain just collapses, right from the bottom up. That is an impact winter.
So far, we've stayed pretty close to home. Now we have to look beyond our solar system. Threat level 4, galactic ghosts. These are the dangers from deep space. They're incredibly rare, but they are unbelievably powerful events that we might not see coming until it's way too late.
We are talking about stars dying in the most spectacular way possible. Things like a supernova or its even bigger, crazier cousin, a hypernova. Now, if one of these things happened close enough to us, and it was pointed in the right direction, it could be catastrophic. The intense radiation, even from thousands of light years away, could literally shred our ozone layer. And without that protective layer, the unfiltered radiation from our own sun would become lethal to life on the surface. So how on earth could we ever get a heads up about something like that? Well, these explosions, they don't just happen instantly. In the final moments before a star collapses, it lets loose this flood of nearly massless ghost particles. And catching those particles is our only real shot at a warning. And this is how we do it. This is SNEWS, the Supernova Early Warning System. It's this incredible global network of detectors, all buried deep underground. They're built to spot particles called neutrinos. See, because these ghost particles barely interact with anything, they escape the dying star's core instantly and travel at almost the speed of light. That means they get here hours, maybe even days before the light from the actual explosion does, giving us our only possible warning that something terrible is about to happen.
Okay, let's move on to our final and maybe our most mysterious danger. Threat level 5, rogue worlds. We're talking about planets that don't belong to any star system, just wandering silently and darkly through the galaxy.
A rogue planet is pretty much exactly what it sounds like, a world without a sun. It might have been kicked out of its original solar system billions of years ago, so now it just drifts through the void, totally dark, bound only by the gravity of the galaxy itself. So let's play a what-if game, a truly chilling one. Imagine an Earth-sized rogue planet, totally invisible until it's right on top of us, passes by at about 3 times the distance to our moon. You might expect some sort of cataclysmic heating or freezing event, but the reality is actually much, much stranger. You'd think that the direct temperature change would be a huge deal, right? Well, the calculations show it would only change Earth's average temperature by about 0.04 of a degree. I mean, that's a statistical blip, so we'd be perfectly safe. Wouldn't we? Well, not exactly. See, the danger isn't the heat or the cold, it's gravity. While the rogue's pull on the Earth would be pretty small, its gravitational tug on our much smaller moon would be immense. It could permanently mess up the moon's orbit, changing its tidal forces on our oceans by as much as 11%. And the result of that? Utterly unpredictable, catastrophic, and permanent changes to sea levels, destroying coastlines all around the globe. So from the solar storms coming from our own star to these silent wanderers from deep space, the threats out there are very real. But for the first time in our planet's 4.5 billion year history, a species actually exists that is aware of them. That's us. We're not just passive inhabitants anymore. We are becoming active defenders. We have the ability to see these things coming and, in some cases, even to do something about it. So the final question really isn't just what our next move is, it's how we're going to choose to shape our own cosmic destiny.